Okay, so let's talk about the applications of autoencoders in this page. So actually, autoencoder can be used in many of the problems as either the model architecture or as a pre-training task. So, because of this architecture properties of autoencoder, it allows it to work in a very, different ways as either an embedding component or as a pre-training component. So we can use the autoencoder in many tasks. So for example, we can use autoencoder for the input embeddings. So given an input with very high dimensional vectors, then we can try to map these high dimensional data inputs into a lower dimensional representation for learning and visualization. So normally in applications, we can have some data sets with very high dimensional vector representations. And if we try to do the learning based on it or do the visualization based on it, it will be very time costly, right? Then we may consider, can we do the dimension reduction of this input or not into some lower dimensional representations. So then we can try to consider to utilize this autoencoder to do the encoding, to do the embeddings, right, for the inputs. So in other words, with the autoencoder, we can embed this high-dimensional data inputs into some low-dimensional representations. So this compact representation we learn, we carry the information we get from the inputs, and it can be utilized for learning and for visualizations. Also, autoencoder allows this data reconstruction and can generate the based on the noise or dirty inputs. So for some cases, if we can train an autoencoder with the noisy or dirty inputs, via the autoencoder we can reconstruct to a clean and good output. If so, then we can use autoencoder for data cleaning and the noisy removing task as well, right? So it allows us to do the data reconstruction and cleaning based on the noisy and dirty inputs. Another way is to use autoencoder for data comparison. So it can be used to reduce the size of data sets effectively with much information loss, because we can ensure we can reconstruct the original inputs based on the embedding results, right? So in this way, we can ensure we don't have much information loss in the process. Also, autoencoder don't require any label information. In other words, it allows us to do this autoencoder in an unsupervised way for representation learning. It doesn't require any label information for representation learning, and it can be widely used in model pre-training tasks. So these are the ways or the main tasks we can use autoencoder in the real-world applications. So as for either for the input embedding, data reconstruction, data comparison, as well as unsupervised representation learning. So, in the following pages, we'll show some more concrete examples of autoencoders for you. Then you can have more idea about how to use autoencoders in specific tasks.